Okay, good. Good afternoon, everyone. I'm a bit sick today, so I'm wearing mask today. My name is Thai, and today I'm going to talk about an open source AI live captioning system that I built that works for technical talks in local language. So, is anyone here an event organizer? Uh, oh, cool. Cool. Yeah. Then I think you may get some benefit from this talk uh, or be able to use this system. But first, maybe let me introduce myself. My name is Thai Pangsakulyanont, and right now I'm a software engineer at EVP Corporation. And the software we built is EventBox. It's like a end-to-end ticketing and event solution. So I think our specialty is like in like music festivals and stuff like that. So if you go to S2O festival or like EDC in Thailand, yeah, we are the provider for managing the event. And as a hobby, uh, I doing tech stuff in Creators Garden, and it is like a community of people who like to create things, and we do like a lot of events. So we run a lot of free events. They are all free and no cost for people to join. And yeah, these are my socials, and I put my username at the top, at the bottom right of the presentation. So let's see. So for Creators Garden, maybe I can show you the Creators Garden website here. Uh, so when we run events, we like invite speakers to speak, and then let's say, and then we archive them into YouTube, and then we use AI models to generate a transcription and chapter, and also the description of the video. So we try to make the contents in the talks in our events as accessible as possible. So that's kind of what we do. And then I went to many conferences that have live captions, and I really like it because I'm not English is not native to me, so it really helps when I watch a talk and then there's a caption. I went to JSConf Japan and then WordCamp Asia and events like that. They have captions for their talk, and uh, we in one of the events that I used to help organize, we use a professional live captioning service, but they are very expensive. And also the captioner, like they can type really fast, but no one can do that in Thai language. Also, nowadays, like last time with Camp 2024, I think they are using an AI system for live transcription. But still, I look at the pricing; they are not cheap, and I uh, didn't see any track record that it will work with Thai language. So that's the reason I built my own. So anyone, uh, let's do more demos. Uh, let's go for demos first. So anyone can speak languages other than English here. Maybe I'll start by saying in Thai. Let's say I'll say this ระบบจะส่งเสียงไปที่ back end ซึ่งเก็บข้อมูลใน SQLite. Yeah, you can see it spells the word back end and SQLite correctly. Any other language you want to try? Anyone come from other? Oh, Philippines? Oh, cool.
Hello po, mabuhay.
Have to wait a little bit. Maybe can you try something like that's a bit more challenging, like has some technical words or like, yeah.
Nandito po ako ngayon sa Thailand, dumadalo ng FOSSASIA 2025.
Wow. Is it correct?
Yeah.
Oh, okay. Yay. Okay, so that was the demo. So maybe, oh, you want to try more? Yeah, yeah, still have some time. Burmese. Okay, that's interesting. I haven't tasted with this language, so maybe go ahead.
mình là open source software conference của đây gọi là bạn đảo đấy.
Oh, right now it thought it's something in Thai. Yeah. So at first, when we try to figure this problem, at first we thought it's going to be simple. We just take the audio from microphone and then pass it to some speech-to-text service and then show it in the front end, right? Well, it turns out it's not that easy because when speech-to-text, usually they use different model for different language. So for example, the last example I said ระบบจะส่งเสียงไปยัง back end ซึ่งเก็บข้อมูลด้วย SQLite. Yeah, if I use the built-in speech to text in the phone or in my PC or in my Mac, yeah, it got the Thai text correct, but the English text is all wrong. Yeah, so yeah, so speech to text is really good in English, but when it comes to local language like Thai, very challenging, especially when there are technical words thrown in. And from my observation, from my testing, most services, when they process Thai speech, they cannot deal with spoken English words. Here's another example from yeah, this. So right now, Facebook, when you go live on Facebook, Facebook is going to generate an automatic caption, and now it supports Thai language. But if you look at the caption, again, it will write, this one is good because it knows it's an English text, but it got the word wrong. Yeah, he said calculator and it says calculator. There are many other words that the model got wrong, and the last one is particularly bad. Yeah. So in 2024, I got my hands on all the models that I was able to find. I test over 20 models, and yeah, I have a 50 minutes talk on this at JavaScript Bangkok. It's on my YouTube channel if you want to look at it in more details. But I take a look at a lot of models and then find the word error rate, WER. This is a metric of how many words they got wrong. So most models have at least 10% word error rate. And practically, it means that every 10 words, I have to fix one word. And that's like not acceptable. So I was able to find only a few models that get the word error rate less than 5%. But it turns out that it was not a speech recognition model. It turned out to be an LLM, multimodal LLM. So the solution that I built is a hybrid between the multimodal LLM and ASR. But what are the difference? Let's look at LLM and ASR first. So large language model, I think they have this thing that's called a broad world knowledge. It knows a lot about the world. And a model that has a broad world knowledge can do something like this. It can correctly transcribe place names or technical terms. Let's say in the context of machine learning, it will know that the word onyx is going to be transcribed as ONNX. Or some speakers, they are very much into VTuber, and if I'm the one doing the caption, I don't know anything about VTuber, I'm going to like struggle a lot trying to caption these words, right? Yeah, and sometimes people speak different language, or some anime names, something like that. Yeah, so it's really challenging if the model is not large enough, it's not going to be able to handle this. So yeah, so this is an oversimplification. So a conventional LM, it has broad world knowledge, but ASR, so an ASR can listen. And some people, they take the output from the ASR and pass it through LLM for post-processing, but still it didn't work well. So there is this thing called multimodal LLM, which are language model that can process, maybe can process text and image, or text and voice, text and audio, text and video. Yeah, most multimodal ones only support image, but a few supports audio. But as it is, so you can see that a multimodal LLM enjoys the benefit of both. It can handle speech and it has a broad knowledge, but still it's a different kind of model. So it doesn't have some of the features that you get in conventional ASR, such as partial transcription, which can give you a transcription as you speak, or word level timestamp, which gives you the timestamp of each word. So with the multimodal LLM, you cannot do that. You have to send the whole block of audio and then get a response. You cannot get the transcription in between. So this is the, so after trying, this is the models that I use, Gemini Pro for its very low word error rate, like 1.4%, and speech matrix for low latency. So the system, it contains like 5 main components. Like we have the audio sender, which is actually an Android, it's a web application, but right now it's running on, right now it's over here. I put it on the speaker here, and basically it's a web application that, yeah, it's a web application that, oh, my screen is locked. Oh, don't worry about it. Maybe you can see later. You can look it up later. But anyways, so we have the audio sender that takes the audio from the microphone and then use voice activity detection library to separate it into blocks. Yeah, this block is called utterance, and then it's going to be streamed to the backend, which save it to the database. And then there is a batch transcriber and partial transcriber that connects to different APIs. Yeah, oh no, the demo is gone. Oops. My apologies. Okay, it should be back now. Yes. So yeah, and then there's a web viewer and editor. So I'll give you a quick demo of how it works. So when I create a room, it's going to generate a few URLs for the viewer, for the editor, and for the audio sender. And on the audio sender side, it's going to look like this. It's just a web application. And when I speak, this bar is going to fill up, and then it's going to send the audio signal. And yeah, that's the, and then yeah, that's the batch transcriber over here. So you can see when, as I speak here, you can see the gray text here. The gray text here is using a partial transcriber. So it's a entirely different model. And then once the utterance is finished, it's going to be sent to Gemini. And Gemini is going to do batch transcription with a large language model. And the great thing about large language model is I can edit the transcription here, and then when Gemini is processing the future chunks of audio, it's going to take into account the edits that I made to the transcription. So by the end of the event, if someone is checking the transcription, you're going to get the accurate one. So that's all for my project. This is the URL. So thank you everyone for your attention.
Thank you very much, Mr. Kai. Any questions?
Lovely.
Thank you.
For the batch transcription, how do you chunk? How do you decide what point to chunk it? And do you overlap the chunks?
Okay, so the answer is the chunk is not overlapping at all, but you can see there is a red line and a green line. If the audio level past the red line, then it is split at that point.
And that's based on the web speech API's utterance chunking.
Yeah, so the voice activity detection model, it takes a block of audio and then it gives you the probability that it is speech. So so I added some smoothing algorithm in there so that if the chunk is too short, it's going to wait a little bit longer before splitting.
And when sending to Gemini, do you convert it to an MP3 or send it as a raw wave? What format do you prefer?
The format that I sent is a WAV file. I think it's actually a raw PCM. I sent it as 16 kilohertz single channel. I think little Indian side. Yeah.
Okay, so I think the thing is up, but because it's the last session, if you don't have any session to go to and you're interested to ask more questions, or in case you feel tired, please feel free. Do you have any more questions? Mr. Dutch?
Thank you very much. It's really amazing work. I had the challenge of looking at my colleagues speaking in Thai in the video call, and I needed to get translated and capture it in English so that on their side as well, when speaking in English, it's really translated back to Thai language. So this kind of tech is really useful. I looked around. I am not sure if that is on the other models like Whisper or other model like Seamless from N4014 from Method. Have you explored those models and how will it be different if it's going to be those models?
Okay, I tried Whisper and Seamless M40 from Meta. I think for Thai language, Seamless M40, the result wasn't good. Whisper is good at about 7% of word error rate. So it's better than the majority of model, which has 10% more. But only like Gemini and the latest one is called Scribe from 11 Labs. They are able to achieve like less than 5%, actually less than 2%.
The Google Cloud also have the text-to-speech model as well, which is totally different. I think from Gemini.
Yeah, they are not good. Not good. Yeah, and I can show you the other slide that of that 50-minute presentation, but I can show it to you quickly. It's opening. Just a moment, please. Okay. Sorry, there's like a lot of slides. Okay. Okay, so here, these are the word error rate that I test from Facebook Live, YouTube, Azure, yeah. And then there is Whisper, right? This is when I try Whisper, it's 7%. And then when I try like Gemini, not sure where is it. Yeah, Gemini is at about 2.5%, but the latest version of the model is like 1.7%. Yeah. Okay.
This is awesome. I tried to use Whisper also to do this. I wanted to do this to learn Thai. When I'm in Thai class, it's mixed English, Thai. But the problem is Whisper gets confused as soon as you switch language.
Yeah.
But there's another aspect that Whisper has, which is called speaker recognition. There's another term. I feel like that could be important. Is that possible with with the way you're doing it. Because sometimes, for example, if you and I are talking, and I want to give your speech more weight, because you're the speaker, and I'm just asking a question. It would be really useful to have, but I feel like it's missing. If you just use a LLM, you're not able to do that, right?
Yeah, I think according to the documentation, the Gemini model is able to do like audio diarization or something. Yeah, that basically tells different speakers apart. They say that in the docs, but I haven't tested yet. Yeah.
In the conventional ML, I think there are models who can differentiate the audio stream.
Yeah.
Separate speaker. So
Yes.
it could be a pre-processing program, but it's not the Gemini.
Yeah. So Scribe by 11 Labs can also do that. It's just released like 2 weeks ago, I guess. Yeah. It can separate between different speakers, and the accuracy is very high, but still from my testing, it's still not as high as Gemini's.
Are you looking at using this at a desktop or offering it to local conferences like this conference or ICON or something?
Sorry, let me check. Okay, so right now I'm using it for local meetups, but still it's like open source and it's not like offered as a service. So to use it, you have to like run and set up some servers. I was in touch with some broadcasters who are interested in using my software, and I sent they have some developers and they were able to run it, and they say the results were pretty good. So yeah, I wouldn't be able to offer this as a service because I have a full-time job and other things to do. But the source code, I'm happy for you to like use it, or maybe even fork it or add translation capabilities. Right now it's just transcribe, but many people have requested translations too.
Can you run it without the mobile phones, like the only or not?
Yes. The audio sender is just a web app. So technically I can run it here, but I would need to get a high quality sound into this machine. So right now, the best way to get the audio easily is putting a phone over there on top of the speakers. So it has all the sounds. But usually when live streaming, I would bring an audio interface and then get the sound from the mixer into the audio interface into my computer. So everything will run in my laptop.
Okay, thank Mr. Tai very much for sharing information today.
Okay, thank you very much.